All right, Mr. Al B. Prompt leaves his house for work at 8 a.m. every morning. When he averages 40 miles per hour, he arrives at his workplace 3 minutes late. When he averages 60 miles per hour, he arrives 3 minutes early. What average speed in miles per hour should Mr. Prompt drive to arrive at his workplace precisely on time? All right, well, let's just start by listing out what we know. Okay, so I'm going to define some variables first of all, just because um, it makes it a little easier to keep track of what we're doing. So I am going to call D, I'm going to say that's the distance. Okay, that's the distance he's driving from his house to work. Okay, and I think we can assume that he's driving the same route every day that he goes to work, and so the distance that he drives when he's driving 40 miles per hour and the distance that he drives when he's driving 60 miles per hour is the same. I think that's a pretty safe assumption since it says that he's going from his house to work, and it's probably the same distance every day. All right, I'm also going to define a variable r. Okay, r is the rate, or I could say, yeah, well, I want to just say that's the average rate of speed. Okay, and we're dealing with, looks like miles per hour, so I'm going to say that is in miles per hour, okay, mph. And the distance, um, given that the units are that the rate is in miles per hour, the distance is going to be in miles. Okay, and we need time, right? Because in one case we know that he arrives 3 minutes late, in the other case he arrives 3 minutes early. And we're going to call this time, we'll just call this is the time that he wants to arrive. We'll say this is the desired time. Okay. And what units are is the time going to be in? Well, if we're working with a rate in miles per hour, maybe I should write it as miles per hour, then our time has to be in hours, okay? And we have to be careful about that because you can see that we're given some times in minutes, and we have to convert that to hours in order to make it work out. Because when we, you know, you've probably, I'm guessing that you know the formula that distance is equal to rate times time. That's the formula that I'm going to work with. So as long as the rate is constant, which we're assuming, or if it's an average rate, that we're assuming that he's at, well, and in fact it says that he's averaging 40 miles per hour and 60 miles per hour. So if we use that rate as the constant rate over time, then we can just multiply the rate times the time and get the distance. Okay. So let's work with what we got. Okay, so we got some more information here too. We've got okay, when he drives 40 miles per hour. So I'm going to write the first case is at 40 miles per hour. At 40 miles per hour, he arrives 3 minutes late. So 40 miles per hour is our rate. I'm going to put, that's R1. And we know that the time that he arrives is the desired time plus 3 minutes. But we have to be careful. We want our time in hours. So we need to multiply this by the number of hours per minute, right? So it's basically 1/60th of an hour per minute, or 1 hour and 60 minutes, alright? So it's 1 hour per 60 minutes. That way we can convert this 3 minutes into hours, and it turns out to be 1/20th of an hour, okay? So I can set up one equation, which is d, and d is constant no matter what, we're going to assume that. So d is equal to the rate, which is 40, times the time, which in this case is the desired time that we want, plus 3 minutes, which is 1/20th of an hour. Okay? So we have one equation. Let me scroll down here just a hair and give us some more room. Alright, so the other information that we're given is at 60 miles per hour. We'll call that rate 2. And the time 2 is 3 minutes early. So the time that we arrive at work is the desired time minus 3 minutes times 1/60 to convert that to hours. Okay, that's probably the trickiest part of this problem, is just making sure that you're working in the right units, because if you're working in a rate that's in miles per hour, then your time has to be in hours. Okay, so that gives us the equation that d is equal to 60 times the time, which in this case is t minus 1/20th of an hour. Okay, so we have two equations. We have two unknowns. We have t and we have d, but we know, or we can assume, that the distance from his house to his workplace is the same every day. So let's just set those two equations equal to each other. That essentially gets rid of d, and then we can solve for t. So let's write that out. We have 40 times t plus 1/20th is equal to 60 times t minus 1/20th. Okay? Alright, so now we can solve for t. So we need to distribute here. We need to distribute the 40 inside these parentheses. So we'll have 40t plus 40 times 1/20th is just going to be 2. And we can distribute the 60 over here, and we'll get 60t minus 3, right? Because 1/20th of 60 is 3. Alright, so we got 40t, we got 60t. Let's get all our t's on one side, and what I'm going to do that, I'm going to subtract 40t minus 40t. That's mainly because I could subtract 60t, but then I'd end up with a negative 20 over here. And I like positive numbers, so that's going to give us over here a 20t, and then this will cancel out. And then we can move the 3 over by adding 3 to both sides, and we'll get 5 over here, right? So what does that tell us? That tells us that t is equal to, if we divide both sides by 20, is 5/20, or we could write that as 1/4. Okay, and that is in hours, remember. Okay, so that's 1/4 of an hour. That's the time that he wants to get to work. He wants to get there in 15 minutes. But when he drives 40 miles an hour, he gets there in 18 minutes, and when he drives there at 60 miles an hour, he gets there in 12 minutes. Okay? But we want to get there in a quarter of an hour. Alright, so let's try and figure out what rate he has to drive at. But we need to find out, in order to find out the rate, now I can take this equation right here and I can actually write it. We want to find the rate. So if I were to take both sides and divide by t, I will get rate is equal to distance over time. I have time now, but I still don't know the distance. I set these two things equal to each other. But if we figure out the distance, we have the information now that we can plug 1/4 of an hour into either one of these equations, and we will get the distance. So let's go ahead and do that. Distance, I'm just going to use the first equation, is equal to 40t plus 2. Now what I distributed here, okay, this is 40t plus 2. Okay. Same thing I got here. It's just a little easier to work with. I got it down here too. I can just plug in 1/4 easier that way. 1/4 of 40 is 10 plus 2, so our distance is 12 miles. Okay, so now I have the distance, I have the time, so let's finish this up. We want to find the rate that will get him there in 15 minutes. Okay, so he wants to drive 12 miles in 1/4 of an hour, so we get that the rate is equal to 12 miles over 1/4 of an hour, okay, and that essentially gives us 48 miles per hour, right? Miles per hour. And, oops, I didn't need to do that. And that is the answer, 48 miles per hour. All right, so there you go.